So in this section, we're going to talk about how to calculate the molar mass of a compound, and then how to use that to convert between moles and mass of a compound, or atoms to mass or mass to atoms of a compound using two-step conversions. Also how to convert between liters of a gas, which is volume, and moles. So the first thing is calculating the molar mass of a compound. A compound CO2 has two elements. It has 1 mole of carbon and 2 moles of oxygen. So that's what the numbers here mean. CO2, 1 carbon, 2 oxygens. So if you look up carbon on the periodic table, it has a mass of 12 grams per mole, and oxygen has a mass of 16 grams per mole. So we have 1 times 12, which is 12, and we have 2 times 16, which is 32. So the mass of the compound is just the total, which is 44 grams. So CO2 has a mass of 44 grams per 1 mole. Now Cu3PO4 we have to break it down to the elements. There are 3 copper atoms, and then the 2 outside the parentheses doubles everything that's in the parentheses. So that means there's 2 phosphorus and 8 oxygen, because it's 2 times 4. And then we multiply by the molar mass of each element, 63.5 grams for copper. Phosphorus is 30.974 grams, and oxygen is 16 grams. So that gives us 190.5 grams of copper, 61.948 grams of phosphorus, and 128 grams of oxygen. Add all that up, and the molar mass of the compound, Cu3PO4 equals 380.448 grams per mole. So another molar mass problem, we have C12, so that's 12 carbons, H22, and 11 oxygens. That's what these little numbers tell us. So carbon, 12 times 12 grams is 144 grams. Hydrogen is 22 times 1, which is 22. And 11 oxygens times 16 is 176 grams. So the total for C12H22O11 is 342 grams per mole. So once you know how to find the mass of a compound, you can now use those numbers to convert between moles and mass. Those numbers that we just came up with were for 1 mole, so now we can multiply that by any number of moles to figure out how much a particular quantity of moles would weigh. Or, in this case, we're actually going to go the other way. So we have 258 grams of sulfur hexafluoride. Sulfur hexa, which means 6 fluoride. So that's SF6. So 6 times fluorine and 1 times sulfur. Sulfur is 32 grams. And fluorine is 18.998, so 6 times that would be 113.988, which means the molar mass of the compound is 145.988 grams. So then to convert between grams and moles, we have 258 grams times 1 mole equals, so this is equals 1 mole up here. 1 mole is 145.988 grams. So we do that math and we get 1.77 moles I'm rounding to 3 significant figures because that was how many significant figures our starting number in the question had. How many grams would you have if you had 2.007 moles of baking soda, which is NaHCO3? So we've got a sodium, which is 23 grams, a hydrogen, which is 1 gram, carbon is 12, and we've got 3 oxygens times 16, which is 48. Add all that together, and NaHCO3 has a molar mass of 84 grams per mole. So 2.007 moles times 84 grams per 1 mole equals 168.6 grams. Ten grams of copper nitrate, copper 2 nitrate, and copper 2 nitrate has the formula NO32, CuNO32. So that's a copper, and the 2 here doubles everything in the parentheses, so it's 2 nitrogens and 6 oxygens. So copper is 63.5 grams. Nitrogen, there are 2 of them, times 14 grams is 28. And then 6 oxygens times 16 is 96. So the total molar mass here is 187.5 grams. So 10 grams, 0.00, times 1 mole over 187.5 grams equals 0.05333 moles. My starting number has 4 significant figures, so my answer has 4 significant figures. What mass would you have if you had 0.06767 moles of sucrose with this formula? We worked out this molar mass in a previous problem. It has a mass of 342 grams per mole. So 0.06767 moles times 342 grams per 1 mole gives me a mass of 23.14 grams. 4 significant figures here, 4 significant figures in my answer. So now that we know how to find the molar mass of a compound and convert between mass and moles of compounds, we can go from mass to particles or particles to mass using the 2-step conversions. So how many molecules of CO2 would you have in 5.88 grams? So remember we said that CO2 has a molar mass of 44 grams. So 5.88 grams times 1 mole over 44 grams means we would have 0.134 moles. Then we're going to take that to do the second step. 0.134 moles times, always, 6.02 times 10 to the 23rd molecules per 1 mole means that we have 8.07 times 10 to the 22nd molecules of CO2. If I had 5.77 times 10 to the 20th formula units is equivalent to molecules, but we don't say molecule for ionic compounds like salt. We call them formula units, but it doesn't make any difference in terms of how you do the problem. So the molar mass of NaCl, sodium is 23 grams, chlorine is 35.44 grams. So the total is 58.44 grams for sodium chloride. So we first have to convert from formula units to moles. So we're going to have 5.77 times 10 to the 20th formula units times 1 mole over 6.02 times 10 to the 23rd formula units, which means we have 9.58 times 10 to the negative 4th moles. And then I'm going to take that number and use it to start the second step, which is converting between moles and grams. So 9.58 times 10 to the negative 4th moles times 58.44 grams over 1 mole means I would have 0.0600 grams of salt. Alright, so in here we're going to just do a couple of conversions involving volume, liters. So 1 mole of any gas at standard temperature and pressure has a volume of 24.414 moles, or we can just use 22.4 liters. I said moles, liters. Alright, so use that in our conversion. So 3.55 moles times 22.4 liters over 1 mole is 79.5 liters. So that's how much volume 3.5 moles of helium would occupy at standard temperature and pressure. And then to convert in the other direction, 50 liters of carbon dioxide at standard temperature and pressure, where 1 mole is equal to 22.4 liters. So 50 divided by 22.4 is 2.23 moles of gas. Okay, so the last bit of this section is what's called the line of equality, and it's basically coming up with all of the possible conversions related to one particular element or compound. For example, 1 mole of water is equal to 6.02 times 10 to the 23rd. That's always true for any element or compound. And that is equal to 18 grams. So we've got the moles here, the number of particles per mole, and then the molar mass of that particular compound. This number changes depending on the element of the compound. This number never changes. And then the second line of equality has just the additional fact where you've got 1 mole is 6.02 times 10 to the 23rd molecules is 44 grams, and also for a gas is 22.4 liters. So just one extra bit to the line of equality. So what would a line of equality be for chromium 3 hydroxide? Well, the formula here is CrOH3. So 1 mole is equal to 6.02 times 10 to the 23rd. That's always true. This would be formula units because it's an ionic compound. Equals, what is the molar mass? Well, you'd have to add a chromium and then 3 oxygens and 3 hydrogens, and that would be a total of 103 grams when you add that all up. And the line of equality for sulfur dioxide, SO2, which is a gas, so we're going to have the extra unit of liters here. So 1 mole of SO2 is equal to 6.02 times 10 to the 23rd molecules is equal to, what's the molar mass here? It's 1 sulfur, 2 oxygens. Sulfur is 32 grams. Oxygen is 16 times 2, which is 32. So we actually end up with 64 grams. And that's equal to 22.4 liters at standard temperature and pressure. So just to last practice problems on these conversions. So we're going to go from grams to liters. And again, anytime you're going from anything to another unit that's not moles in this type of equation, you need 2 steps. You need to convert to moles first and then go to the second unit. So 4.66 grams of sulfur dioxide, and we just said that 1 mole of sulfur dioxide has a mass of 64 grams because it's 1 sulfur and dioxide, 2 oxygens. So this is 0.0728 moles of sulfur dioxide, and then I need to convert that to liters because that's what the question wanted to know. So 0.0728 moles times 22.4 liters per 1 mole at standard temperature and pressure is equal to 1.63 liters. And converting formula units to grams, so this is similar to other problems we've done prior to this. So this time we're converting from formula units, which is equivalent to molecules or atoms, doesn't matter, it's particles. 6.02 times 10 to the 23rd, 1 mole, means that we have here 14.95 moles. Take that, and we need to get to grams, so 14.95 moles. The molar mass of magnesium chloride, it's 1 magnesium, 2 chlorines. That adds up to 95.3 grams. And 14.95 times 95.3 is 1,424 grams. But I only had 3 significant figures in my starting number, so I have to actually round that to 1,420 grams because this answer has 4 significant figures, which is too many.